Welcome to my channel. We are going to discuss about the limit by L'Hopital rules. We have given two functions fx and gx, which are differentiable functions of x, and we have the first case first, that if fa equals to 0 and ga equals to 0, then limit x tends to a fx upon gx equals to limit x tends to a f dash x upon g dash x. What is f dash x? F dash x is the first derivative of f, and g dash x is also the first derivative of x. In general, if f a if f of a and first derivative of f at a and second derivative of f at a and n minus 1th derivative of f at a equals to 0, and similarly for ga and first derivative of g at a and second derivative of g at a and also up to the n minus 1th derivative of g at a equals to 0, and and nth derivative of f and g is non-zero, then limit x tends to a fx upon gx equals to limit x tends to a fnx upon gnx. And again, second, if limit x tends to a fx equals to infinity and limit x tends to a gx equals to infinity, then limit x tends to a fx upon gx equals to limit x tends to a f dash x upon g dash x. In general, similarly, if limit x tends to a equals to limit x tends to first derivative of f at x and equals to, and similarly limit x tends to a f n minus 1th derivative of f is infinity, and limit x tends to a gx equals to limit x tends to a g dash x and limit x tends to g n minus 1th derivative of x equals to infinity, then limit x tends to, and the limit x tends to a nth derivative of f at x is non-infinity, and limit x tends to a g nth derivative of g at x is also not infinity, then limit x tends to a fx upon gx equals to limit x tends to a f nth derivative of fx upon nth derivative of gx. We are going to discuss this about by the following examples. The first case is called the 0 by 0 form. This is called the 0 by 0 form. This is called the 0 by 0 form. Why 0 by 0 form? Because x tends to a equals to 0 and ga equals to 0. So this is called the 0 by 0 form. Again, the second case is called infinity by infinity form. This is called the infinity by infinity form, since the this tends to infinity and this tends to fx tends to infinity as x tends to a and gx tends to infinity as x tends to a. Therefore this is called the infinity by infinity form. And if 0 by 0 form and infinity by infinity form is found anywhere in the limit, we use the L'Hopital rule. So again, we are going to discuss this rule by the following examples. The first example is, we have first example given is limit x tends to limit theta tends to pi by 2 sec theta minus tan theta. So we are going to solve this limit by using the L'Hopital rule. So we can write it as limit theta tends to pi by 2, and this can be written as sec theta can be written as 1 upon cos theta, and sin tan theta can be written as sin theta upon cos theta. This can be, and this is equals to limit theta tends to pi by 2 1 minus sin theta upon cos theta. Since we know that sec theta is the reciprocal of cos theta and tan theta equals to sin theta upon cos theta, we have used simple trigonometric formulas, and at 1 minus sin theta equals to 0, at theta equals to pi by 2, since sin pi by 2 equals to 1 and 1 minus 1 equals to 0, and cos theta equals to 0 at pi by theta equals to pi by 2. So this is the 0 by 0 form. This is 0 by 0 form. So we use L'Hopital rule. What we do first? First we differentiate numerator and denominator with respect to theta. First derivative of 1 is 0 and sin theta equals to cos theta and cos theta equals to minus sin theta, and this becomes limit theta tends to pi by 2, and this is cos theta upon sin theta. Again this becomes the, since sin theta sin pi by 2 is not equals to 0, so we can put the values of the theta. So cos pi by 2 upon sin pi by 2, and this becomes 0 upon 1 equals to 0. This is the limit of the given problem. Again we have second problem is, the second problem is, we have second problem. What is the second problem? The second problem is limit x tends to infinity 0 to x e x square dx whole square 0 to x e 2x e raised to power 2x square dx. By substituting the values, this is if x tends to infinity and ex tends to infinity, e raised to power infinity equals to infinity and e raised to power infinity equals to infinity. So this is the infinity upon infinity form. This is infinity by infinity form. So we use here L'Hopital rule. So what is L'Hopital rule? L'Hopital rule, we first of all we know what is the difference, how can we differentiate the integration? So we use Leibniz rule. What is Leibniz rule? The Leibniz rule is this. Leibniz rule. If hx, gx and fx dx, y equals to hx, gx, fx dx, and if we have to find out dy upon dx, then what we do? First of all we differentiate g dash x, and we find out the composition of f of g x minus then h dash x and composition of f of hx. Again we use this formula in differentiating numerator and denominator. So in the given problem we have gx equals to x and hx equals to 0 and fx equals to ex square, and this is the infinity by infinity form. So limit x tends to infinity, the differentiation of x square equals to 2x, so this becomes 0 to x ex square dx, and again we differentiate this. What is the differentiation? Differentiation by this Leibniz rule. This Leibniz rule, dy by dx equals to, first of all we differentiate numerator and then we differentiate denominator. Then g dash x, what is g dash x? Gx equals to x, so this is g dash x equals to 1, and f of gx e, this becomes ex square minus h dash x is 0 and this e0 square. So and again in numerator, in denominator we have differentiation of x is 1 and this is becomes e2x square minus differentiation of 0 and this is e2 0 square. So again this becomes limit x tends to infinity, this becomes 2 0 to x e raised to power x square dx, and this becomes ex square again, and this becomes e to x square. Again, limit x tends to infinity to 0 to x ex square dx upon e 2x square minus x square. Why? Because we subtract the power by division rule. The power rule, limit x tends to infinity to 0 to x ex square dx upon ex square. So again, this is also in the form of infinity by infinity. Again, we use L'Hopital rule. In generalized L'Hopital rule is we can differentiate any time we can until the denominator becomes non-zero, non-zero or non-infinity. So we are using generalized L'Hopital rule here. So again, limit x tends to infinity, this constant 2, this is constant 2, and this is differentiating again, this is limit x tends to infinity, differentiate numerator using Leibniz rule that we have mentioned earlier. The differentiation of x is 1, and this at the place of x we composite ex square minus the differentiation of 0 is 0 and e0 square upon e, the differentiation of ex square is x square is 2x and ex square, and this becomes limit x tends to infinity to ex square upon 2x into ex square, and ex square becomes goes to cancel, and 2 goes to cancel, limit x tends to infinity 1 upon x, and this is equals to 0. Since 1 upon infinity, 1 upon any larger number is, x tends to infinity means x going to a larger real number, largest real number, and 1 upon largest real number equals to 0. So the we have the answer of the above integration, above limit is, this is equals to 0. And again, we are going to solve another problem. What is the another problem? The another third problem is given here. This is the third problem. The third problem is, this is A. Again, we check that what is the what is the form of limit. So we have given limit x tends to 0 gx, x tends to 0, x tends to a, sorry, limit x tends to a, this is limit x tends to a, limit x tends to a, gx fa minus ga fx upon x minus a. And what is, if we put x equals to a, then numerator becomes ga fa minus ga fa, which is equals to 0, and denominator a minus a equals to 0. So this is the 0 by 0 form. So 0 by 0 form, then we use, again we use here L'Hopital rule by differentiating numerator and denominator. So first of all, differentiate numerator, limit x tends to a, by differentiating with respect to x, g dash x fa minus ga f dash x, and this becomes 1. Again we put the value of g dash a fa minus ga f dash a, and this becomes 2 into ga equals to minus 1 into 2 minus the ga equals to g dash a equals to 2 and fa equals to 2 minus g of a equals to minus 1 and f dash a equals to 1. Then this becomes 4 plus 1 equals to 5. This is the required answer of the given problem. So we have solved 3 examples using L'Hopital rule.